Good morning, everybody, and thank you for the opportunity to present this paper to all of you. So last year, we finished our presentation on Monte Leone, stating that we can firmly say that our research project has confirmed many of the observations made by the 19th century explorers, among which Silman certainly played the major role. The questions raised by these megalithic structures that run for more than a dozen of kilometers remain at present moment without certain answers. It would be ideal that the project, after the mapping phase, can continue with targeted archaeological excavations of the most significant features such as the necropolis or the village mentioned above. In June 2021, in order to identify the chronology of the structures, the project financed a campaign employing OSL dating methodology, optically simulated luminescence, performed by the Laboratorio Lambda of the Department of Material Science of the University La Bicocca of Milan. The results of which should be revealed in the late fall 2022 and therefore can be discussed in the presentation at the annual meeting 2023 of the Archaeological Institute of America. So, as promised, here we are to share with you all the results of the scientific dating carried out at Monte Leone. So let's start with the science behind OSL dating. Optically simulated luminescence dating, or optical dating, provides a measure of time since sediment grains were deposited and shielded from further light or heat exposure, which often effectively resets the luminescence signal. This technique, as thermoluminescence, was originally developed in the 1950s and 1960s to date fired archaeological materials, like ceramics. Ensuing research in the 1970s documented that marine and other sediments with prior sunlight exposure of hours to days were suitable for thermoluminescence dating. Discoveries in the 1980s and 1990s showed that exposure of quartz and feldspar grains to a tunable light source, initially with lasers and later by light-emitting diodes, yield luminescence components that are solar reset within seconds to minutes, expanded greatly the utility of the method. In the past 15 years, there has been significant advances in luminescence dating with the advent of single aliquot and grain analysis and associated protocols with blue or green diodes that can effectively be compensated for laboratory-induced sensitivity changes and render accurate ages for the past, let's say, 150,000 years. Most recently, the development of protocols for inducing the thermal transfer of deeply trapped electrons has extended potentially OSL dating to the 106-year timescale for well solar reset quartz and potassium feldspar grains for aeolian and littoral environments. Regarding the methodology, OSL dating is based on an estimate of the period in which a mineral, preferably quartz or feldspar, present naturally in the rock or sediment, from an initial condition of exposure to sunlight, which is the geological zeroing, passes to a permanent condition of darkness maintained even during the sampling, and this is important. Sampling is normally carried out in dark conditions by taking both a surface sample of the rock resting on a substrate, which is the rock surface, and a corresponding sample of the substrate or sediment underlying the rock, the sediment. The results of the two samples should be very similar, assuming that both were obscured at all times at the same time, and this indirectly provides an estimate of the quality of the measurement. However, it should be emphasized that taking the surface sample of the rock is simpler and is less subject to errors due to the pollution of materials from other contexts, as can instead happen in the taking of the sediment. So let's go through some archaeological biases. In the case of samples taken from structures of anthropic origin, typically masonry construction, dating errors could essentially arise from two different conditions. The first one is when the lithic material used may have been taken and placed on site without sufficient exposure of the surface to sunlight necessary for the zeroing the luminescence. In this case, the dating can even go back to the geological formation period of the stone. And second, after being exposed to light and placed on site, the lithic material passes into a condition of darkness and for some reason is subsequently temporarily re-exposed to light, causing a new zeroing of the luminescence. In this case, we have a post-dating that coincides with the last episode of exposure to sunlight. Both sources of error can be corrected by analyzing a suitable number of samples of the same structure and studying the statistical distribution of the readings. However, this procedure is not always possible. The OSL dating of Monte Leone covered 4 main sites from northwest to southeast. They are the Mangiatoie, the Porcareccia, the Vaccareccia and Uccellina. So let's start with the Mangiatoie site. This is a fortified settlement nestled into the forking of the lower wall of the Stillman's corridor. On its southern and northeastern sides, about 23 meters in length, it presents, resting on the said lower wall, a double wall with the internal one still visible in elevation, with a perimeter of about 73 meters and a total area of about 325 square meters. The first sample, 1A, was taken at the base of the internal wall near the southwestern corner of the perimeter. This sample provided a date of 1140 BC with a rather high approximation equal to plus minus 680 years for the rock surface, whilst the sediment provided a medieval date of 1220 AD with margins of plus minus 120 years. The dating of the rock surface places the structure in the late Bronze Age. However, considering the error margins, a date between the early Bronze Age to the second half of the 5th century BC can be assumed. The early dating of the sediment, which is plus 2,360 years, seems to be incongruous, and it might be due to the possible contamination of the sample, which is usually not easy to collect, or to potential subsurface mixing of the same sample in following periods due to bioturbation or human intervention. The second sample, 1B, was collected from below a megalith buried in the center of an oval circle of stones outcropping within the southwestern section of the same settlement. This oval substructure could be interpreted as a burial, although no excavation has so far been undertaken to confirm it. In this sample, the rock surface could not be dated, while the sediment gave a date of 790 BC with margins of plus minus 410 years. The low chronological margin of this phase places the dating at around 1200 BC at the end of the Middle and the beginning of the Late Bronze Age, which could in fact be congruent with the real dating of the settlement, if we compare it to the masonry technique and the style and the Late Bronze Age ceramics attested inside the nearby apical Castelliere, which is structurally similar to the Mangiatoie. Let's move to the photos of the Mangiatoie samples. So the first one, the second one, and then the team collecting the samples. And then let's talk about the Porcareccia site. This sampling was carried out downstream at about 250 meters east of the Mangiatoie, in a section where the low wall of the Stillman's corridor has been literally cut by a torrential watercourse, probably due to repeated flooding episodes. The bell-shaped section of the wall is here clearly visible, making it therefore possible to take the sample, which is 1C, from the center of this section, from under the first row of large stones resting directly on the substrate from which the sediment sample was actually taken. The dating of the sample taken from the rock surface has given a very early date of 7,950 BC, with a rather high margin of plus minus 1,260 years, suggesting therefore a Mesolithic phase. This date is greatly contrasting with the one obtained by the dating of the sediment, which is giving a medieval phase dating to 1240 AD plus or minus 90 years. Both dates seem anomalous, and another sampling of this specific area should be carried out to confirm or deny the two dates. These dates cannot be, however, discarded just because they do not fit the chronological narrative of the site so far, but they certainly need to be reassessed. The medieval dating of the sediments, which is very similar to the medieval dating of the sediments of the Mangiatoie site, could again be attributed to contamination due to human action or bioturbation, or in this case, very likely, to the action of the alluvial water flow. The next site is the Uccellina site. This sampling site, sample 4A, corresponds with the cut of the highest part of the wall of the Silman's corridor caused by a small track across the wood. The sampling point is located at about 100 meters from the beginning of this wall, which at this point seems to detach itself from the lower wall and then proceeds parallel to it for about 3 kilometers, and thus forming a sort of corridor, hence the famous Silman's corridor. It must be said that the small track seems to cut through the wall at an intermediate height, as the collapse of the wall appears here to be flattened and partly buried in this section. The dating of the rock surface of this sample falls at about 700 BC with a margin of plus minus 420 years. This gives us a chronological phase between the end of the Bronze Age and the beginning of the Iron Age, which saw in this area the Romanization of Etruria. It is possible that the sampling was polluted with later material and sediments, or perhaps the wall has been maintained and restored in later phases. This interpretation is plausible as the sample was taken at a higher level along the wall and not at its base, where it was cut by a track which is not possible to date at the moment. Perhaps a sediment sample of the track should also be taken. And the last site is the Vaccareccia site. This sampling site is, in our opinion, very significant, as it was taken at the exact junction of the low wall of the corridor and a secondary wall which branches off to completely embrace the top of the hillock at about 250 meters above sea level, and then rejoins the same wall at about 300 meters northwest of the sample point in question. The sampling point was located inside a collapse of stones circular in plan and suggesting perhaps the presence of a tower inserted in or abutting the wall itself. This collapse had previously been removed by the volunteers of the various associations participating in the project. This cleaning up was carried out to specifically reach the base of the structure in order to carry out the appropriate sampling. Here, two samples, 5A and 5B, were collected at the base and inside the circular structure. It is reassuring that the dating range of the two samples is, in this case, very close, and so is the dating range between the rock surface samples and the sediment samples. The dates of the two samples, including both the rock surface and the sediment, fall within a range of just over a millennium, about 1,160 years. Or, to be more precise, from 3,280 BC to 2,120 BC. Considering the more distant dating of 5,300 years, The range of 1,160 years corresponds to a spread of 21% margin, and this is acceptable, especially considering that the error margins in the individual samples are low, ranging from 140 to 270 years. This gives an error margin of 2.8% for the two samples with the earliest date, samples 5A and 5B, both sediment, while it is equal to 6.5% for the sample with the later date, which is sample 5B and is a rock surface sample. The chronological phasing of this site falls therefore between the Neolithic, which is the earliest date, and the early Bronze Age, which is the later date. Considering that the sampling was carried out within a wall collapse, representing a sealed context, the dating from this sampling is therefore of significant importance for the entire site. And here are a couple of photos of the samples collected at the Vaccareccia. So to conclude, despite the methodological biases and the chronological dispersion, the data of this first dating campaign carried out along the walls of Monte Leone and associated structures had produced significant archaeological and chronological indications. The first one is that the late dating, the Roman to medieval one, given by the sediment samples at Porcareccia, sediment 1C, and at Mangiatoie, sample 1A, seems to be the result of sample pollution, and as it contrasts too much with the respective rock surface samples, it could be discarded unless more sampling is carried out in a more controlled method. The earlier dating from the samples instead would also be supported by the ceramic character of both sites, which is typical of earlier settlement sites nearby. The second point is that the late Bronze Age dating given by the rock surface sample 1A, which is 1140 BC plus minus 680 years with a margin error of 21.5%, is supported by the later margin date of sediment sample 1B, which is 790 BC plus minus 410 years, giving an approximate date of 1200 BC, which seems to be reliable enough if compared also to structure typologies and construction techniques of already known sites. Further scientific sampling during or after archaeological testing inside the structure would be desirable in order to confirm the dating of the structure itself, because this might not be contemporaneous to the wall which seems to abut. And the third point is that the dating of the walls of the so-called Stillman corridor, samples 1C, 4A, 5A and 5B, seems to cover three different chronological phases. The rather vast chronological period of the Porcareccia, spanning from a very early date of 7150 BC, given by the rock surface sample, which, despite being rather anomalous, it cannot be excluded a priori, to the very late date of the sediment sample of 1240 AD. The second phase is the Iron Age dating provided by the Uccellina samples, which is more or less 700 BC plus minus 420 years with error equal to 15.44%. And the most significant dating provided by the Vaccareccia samples, samples 5A and 5B, which are given a date between the Neolithic and the early Bronze Age. This dating would also find comparisons in Sardinia with the Neolithic site of Monte Baranta and other sites of the so-called culture or cultura di Monte Claro. So this is the evaluation of the first attempt at scientific dating of a site which has proved to be extraordinarily and unexpectedly complex, but lacking almost completely material culture associated with these types of walls and structures. We hope to substantiate the topographical survey of the structures already carried out with archaeological excavation samples along the most significant points identified during these 4 years of the Monte Leone project, to be able to answer all the questions and fill in the chronological gaps presented by this site. And while we say thank you to the team of the Lambda Laboratory of the Bicocca University of Milan for the invaluable collaboration, a collaboration we so hope to continue, we would like to add that with excitement and determination our research will carry on persistently. So thank you very much.